Welcome to Reinventing Broadcast, where AI meets content. Here we have a bonus episode for you. Let's dive in.
Hello, everyone. Welcome back to the show. This week, we've got Teju Mulagada on the show. Welcome to the show. I always like to ask, tell us a little bit about yourself and how you got into the industry.
Yeah. Hi, Ben. Thank you so much for having me. I'm super delighted to be here. And a little bit about myself. I'm Teju Mulagada. I go by Teju. I'm a technical program manager, growth strategist, and an entrepreneur, really passionate about scaling operations, teams, revenues through agile strategies and go-to-market planning and AI-driven innovations within broadcast media. Yeah, so a little background of how I got into the industry here. So
Yeah,
I went to school for computer science, and I've been in the uh, computer science corporate IT for the past 10 years.
the dark
And
side.
yeah, uh, it just changed so much too, I would say, but I've always been very, very passionate about systems, building efficient, scalable tech solutions I was very, very passionate about. I think about maybe 2.5, 3 years ago, a friend of mine, Brian, he works as a consultant. He's a great engineer and architect. So I literally was like passing by one day and he's like, oh, there's this new role as a broadcast engineer. Do you want to give it a shot? And I was just like, you know what? Sure, why not? This sounds very interesting. I would like to try it out. And that's how I broke into the industry as a broadcast engineer. And my first project was with Yes Network. Um, uh, we were integrating we were revamping the entire studios in Connecticut. And I was working alongside these amazing engineers. And Yusuf, his name is, he's the one who taught me a lot. And once I'm the kind of person, once I like something, I would just spearhead the learning. I get very passionate and I'm just a quick learner. And that's how I started getting into it. And I picked up on various things, and SMPTE really, really helped. And also professionals like yourself sharing a lot of information about the industry. So all of that really helped me and helped me learn. And yeah, 3 years later, I'm still here. Wrote a research paper, presented it at SMPTE, and yeah, trying to contribute as much as I can. And yeah,
Yeah,
that's a little
because
bit about.
it sounds like you're still sort of grounded in the tech, but you've added on this sort of consultant sort of vibe and the sort of entrepreneurial spirit. And actually, SMPTE is like a household name for standards, right? It must be
Yeah,
really like exciting to get into that.
yeah, it is. Just like um, kind of like tying passion to goals in a way. Meaning, like coming from an IT background, I was able to quickly spot the gaps in the broadcast industry from like inefficiencies in workflows, having processes like standard efficient processes while integrating or within the workflows itself, within the project management and things like that. So as soon as I came into the industry and I understood those gaps, my goal was to bridge these gaps by bringing efficient solutions from what I've learned and how to embed them differently within media industry. So yeah,
Yeah,
and in
yeah.
that, SMPTE was a great help. Learning their standards and the processes, digging into IP-based networks and things like that, it just really, really helped as well.
Yeah, I guess the corporate IT sort of networking background really lent itself well. Because what's the famous standard? ST 2110. That's the talk of the
Yeah,
town, right?
SC 2110.
Yeah,
Yep. Hmm.
yeah. And is that what your research paper is based on?
Yes, Ben. So yeah, my research paper is based on. It's kind of like In short words, I would say I kind of went in and within the workflow ST2110, how can we embed AI? How can we make these IP-based workflows more efficient? So that's what I concentrated on, and that's what my research paper is based on. I would
Yeah,
love to dig
because
deeper into it.
you've presented it right already, but back in November or December.
Yeah, yeah. October, I presented it at SMPTE MTS 2025 in October in Pasadena. Great response, and just so many people coming and talking about it, talking about how we can leverage those systems within the IP 2110 architecture. That was phenomenal, and I cannot wait to see where my research goes further, and like how it's going to be actually all the use cases, the worst use cases come into play, and how it's going to transform.
Yeah, yeah, because everyone was talking about 2025 was the year of agents, but this is
Agents.
multi-agent. That's what caught my eye. It's multi-agent solution, is it?
Mm-hmm. Yeah, yeah. So just a little overview. My paper is it's titled "Leveraging Multi-Agent AI Systems for SIMT 2110 Broadcast Automations." As I mentioned, it's literally like within the automation broadcast workflows, how can we add these multiple agents in different areas and make the workflows more efficient in solving metadata issues or latency issues, things like that.
Right. Okay. I mean, I read through it. It's a fantastic research paper, and we have a big sort of technology audience as well. So I'd like to talk a bit about the architecture. So walk us through why these three separate agents is preferred rather than just like one big AI system handling everything. Why is it three separate agents?
So ST2110 has like transformed broadcasting by enabling like flexible IP transportation within video, audio, metadata. But it's also facing so many challenges because people are so used to the traditional um, integrations. So coming in, there are so many unknowns. There's so many like how to handle issues within the workflows, right? So, but the major challenges include manual metadata tracking. That's a biggest issue within the IP workflows. And the second issue is static buffer management. With all these high bandwidth streams, the buffer management becomes very tedious, and this it's so error prone to error because of these reasons, and these are the specific issues I really concentrated on, and that's why if we have multi agents each tracking all these individual issues separately and come together with a human governance, someone actually monitoring how each of these agents is performing. Um, are there any issues? How can each agent be improved in resolving that specific issue? That's what I concentrated on. That's what the architecture is majorly like concentrated on. And um, that's the reason why I proposed a multi-agent system in here.
Yeah, yeah, because metadata is always a problem, right?
Yeah.
And the desynchronization of it is probably a pain point which all the broadcasters sort of deal with.
Mhm.
Can you go a little bit into the sort of metadata agent and how that sort of helps remedy that?
Okay, so digging a little deeper into each of these agents. So there are three agents that are going to be talking to each other at the same time, working on solving three different issues that are going on. Looking at the architecture itself, this multi-agent system architecture, it has one large language model sitting in center, and within the entire ST2110 workflow. And we have three agents. One is the metadata tracking agent, a queue buffer agent, and a configuration agent. So these individual agents, metadata tracking agent is tracking all the metadata, looking at the anomalies, any disturbances within the metadata. And that data is connected to the large language model. And also there is a queue buffer agent. This queue buffer agent is individually only looking at the buffer streams. And if there's any spikes within the stream, the transmission of the data packets, there's any spikes there or there's any disturbances within the streams. So this buffer agent is managing all these things related to that stream. And the third agent is the configuration agent, and it's managing all the configuration details. Within the workflows, there are so many devices we're talking to, from an audio perspective, video perspective, metadata. And from all these devices, we have so many configurations and connections. And it's very, very hard to track where a connection is coming from, a configuration is coming from, something goes down. And this specific configuration agent is sitting there just to track all those, if all the connections are going in flow, any issues in the configurations itself, things like that. So all these three agents will be working on their specific task individually and tracking, and they will be talking to the large language model. And this entire process has a human oversight and constant monitoring of the issues on how to improve everything. And this tied to a large language model, this large language model is consistently taking the data, best case scenarios, worst case scenarios, and improving, self-improving within the workflows itself. So this is kind of like an
Yeah.
entire architecture that was proposed in my paper.
Yeah, it's interesting to say about the sort of human override, because I was thinking about the agent's recommendation. I understand there's like some orchestration in there. Is that the part where, the human in the loop could decide to override a recommendation, for example?
Yes. So each agent, they give a report statuses. They have specific tasks going on, but all of these are set by humans. A human operator
Yeah,
are the one who are sending feedbacks, delegating the tasks for these agents individually and on a whole, setting rules for each of these agents. This is all done by humans, the human operator.
yeah,
Yeah, they're
that's
kind of like
great.
the trainer, like the high level person. How, in easy terms, how I would put this is, it's kind of like all these agents are little employees of, and the human operator is managing these employees. I would say treating agents as employees with set of responsibilities and roles. And yeah, that's how I kind of like see it.
Yeah. No, it's great you've designed the human oversight into the solution as well. Um, yeah, I mean, I'm always thinking about this, and also stuff around that, like trust and governance.
Mhm.
Because if you try to introduce any change into a sort of broadcast operation, there's people always, skeptical about even just, traditional broadcast technology,
Mhm.
never mind AI. Um,
Yeah, but
so
it's
like,
it's so it's
how,
so unrealistic, because there is so much that goes within these streams, when within these workflows. It's so hard for a human to come in and just like dig into the issue. It will take a day, sometimes it will take 3 days just to figure out why the issue happened, why it's going on, and things like that.
yeah,
And
yeah,
that's the
is that
kind of
one?
overhead we want to take away.
Yeah, yeah. Because I guess, showing an operator something like that,
Mhm.
that would build confidence, right?
Yeah.
Because I'm always thinking of change management and how would we get people on board. It's
Mhm.
like, sort of lift the lid on it, show it what it can do, right? And instill that confidence in the operators.
Yeah. And then so it's so some of the issues, for example, um um like jitter, like IP packet jitter or bursty traffic. They can be sometimes very unavoidable. And we've all battled those in like live productions, and they can get really ugly when in live production, so this
Yeah,
multi-agent comes in. It has also a predictive mechanism, not just okay what the issues are. It has a predictive mechanism as well, which also like okay, there's a there might be an issue going on. We will report this, so necessary steps can be taken to avoid this during a live production.
yeah. And the sort of, I was looking at has it got something like a self-recovery rate? Because it was quite high. Was it like in above 90%?
Yeah. So because of that self recovery rate, since all these agents, they're talking, but what kind of action are they taking? How are they improving? And that's where the large language model, the LLM, comes into play, and how it takes up all the issues and uh, relearns how to do things better and things like that. That's where all that training is going on, and it's self improves on avoiding any issues that are coming in from the get go.
Yeah. And then the other remaining few percent, is that just handled by operations then?
Yes. I mean, we can't say 100% until you actually implement it and like see how great it's trained. And also, every workflow is different. Every single
Yeah,
workflow is different. So it is hard, and reaching to 100% is a dream, but it's also
yeah,
can be a little harder.
yeah, because I guess every client implementation is different as well.
Mhm.
And, people are aiming for perfect, and most cases, you're not going to get perfect.
Yeah.
But with AI, and we see it across the industry,
hmm The
is,
more it learns, the more
AI's,
it helps.
yeah,
It's kind of like that.
yeah. And, for an AI to score, 95%, say, whereas a human couldn't get to that level anyway.
hmm
So in that respect, it's like, well, you're just dealing with the edge cases, probably.
Yeah.
Yeah,
Yeah.
exactly.
So it's kind of like I'm literally looking at like the three critical bottlenecks. So every broadcast engineer has fought these. The
Yeah,
metadata tracking, processing these ancillary data, um, and detecting anomalies like format inconsistencies. It reduces like manual verification overhead. We don't
yeah,
have to. The AI is all going to handle that for us. And when it comes to like configuration management, it ensures stability in live environment or any kind of misconfigurations within the monitoring. It detects and like um, just monitors and gives a heads up if anything is like unstable or coming up to a live production. And when it comes to the queue buffering, it's just like um, just mitigates the latency issues. Even if it can like solve few latency issues, that would be phenomenal because latency issues
yeah,
are huge. The it um Also like handling dynamic loads within the transmissions and things like that. Um, yeah, so the goal is to resolve these three bottlenecks we always have. So these are the three
yeah,
bottlenecks I was trying to solve.
yeah. I mean, that's going to be great help for broadcasters. And like, where is this thing running? Is it just in the lab, or is there any live implementations of this anywhere yet?
So unfortunately, I was not able to get to any live implementations for this. in real time. I'm still working on connecting with someone who we can implement this like live. But as of now, it's super in the lab. Just all the data I've gathered is through examples of case studies that exist in that already are out. Someone like reported the case study, and I took that issue and like worked on it. So that's what so far that was the progress on the research paper.
So yeah, I'm always interested in like, engineering teams' opinion on this. Are people eager for this? Have you spoke to engineers in the industry? Is there any pushback, or are they sort of eager
Yeah, they're
to
actually
learn about this technology?
very
And
eager. Like I said, I've spoken
yeah,
to so many people who attended my talk at the conference and things, and I've met some university students from Dublin, and they are majors in semiconductor industry, and they came to me and they were like, oh, this is a great architecture. Do not limit yourself to just broadcast media. This can be useful in like other
oh,
places as well, in semiconductor industry, and like so try and like expand the solution a little more is what they suggested.
oh wow, yeah, exciting,
Yeah.
eh? And let's talk about SMPTE
hmm
2110. So why is that, compliance non-negotiable for this solution? Why was it chosen?
Mm, so ST2110, I mean, the entire internet works on IP transmission, and we love it, don't we?
Yeah, we
We
have
have
to,
to, right?
I
So
guess.
that's my exact point when it comes to broadcast media. IP network transmission is a game changer. It just is the next step within the broadcast media, going from uh, traditional to IP network enables broadcast to go in other directions from IP, like cloud or embedding AI within. When it comes to traditional models, advancement is very slow, and it just is very difficult in very various aspects. So always I wouldn't say a fully IP-based solution is the solution too. There are some advantages of on-prem SDI kind of workflows, but ideal use case, I would say, would be a combination of IP, network, ST2110 workflows with a little bit of traditional workflows and cloud, everything within in there in those use cases is what I think.
Yeah, because I mean, everyone's ripping out SDI and putting in ST2110 anyway,
Yeah,
right?
we have
And
used SCIs for what? How many years is that? You would be better
yeah,
no, to answer me that.
yeah, and I can see it like in like newsrooms or sports. This thing's going to be pretty
hmm
crucial, right?
Yeah, uh, it's kind of like we have been on SDI for what 20-30 years, and what's the advancement in it? We've only
Yeah,
gotten to a
yeah,
point and not further than that.
yeah. And just a bit more about adoption in general. So, like, is there any sort of retraining needed for people?
Yes.
I'm just imagining, like, people would have to be trained on this
hmm
thing, right?
Yes, definitely. So this is the biggest challenge I see as of now is the uh, educational gap, the learning gap. Um,
Yeah,
it is phenomenal. The IP SC2110 workflows are great within it, but not many integrators are well aware of what goes into a ST2110 integration. So there's a huge knowledge gap. And that's where, to
yeah,
me, when I was coming in and trying to learn everything, SMT was a great help. They have so many amazing resources. so many courses. Even if you're a person who do not know anything about the industry, you can come in and learn about everything from the SMPTE content. So that's my
Yeah.
take, but
Yeah.
there is definitely a huge knowledge gap, and which needs to be filled. Every company should take some time,
Yeah.
some efficient steps to fill that education gap, to advance the
Yeah.
industry. And we are still talking about the
Yeah.
IP networks. We're not even getting till AI yet. The world is moving towards like AI. How can we
Yeah.
like just still have this much of knowledge gap within these workflows? And then how are we going to include AI within this?
Yeah. Even they're going to need like formal training programs and stuff to not only get up to speed with the standard, but also introducing, agentic multi-agent AI
Hmm.
as well. Um, and just putting your sort of technical program manager hat on, how long do you think, between sort of the lab or a pilot to sort of live production could this agent-based, multi-agent-based solution be implemented? Is it months or is it going to take years, or
No, I definitely
has
see it
that
in
been
like
even
months.
scoped
It
yet?
can be implemented in months. As I said,
Yeah,
it's um, AI, it improves as the model trains, gets more data, sees more live action, like issues, what's going on. So I would say it,
yeah,
um, you will see results in months. Um,
yeah. And then the models continuously being
uh-huh.
trained, right?
They're
With
continuously.
live
Mhm.
production
So
environment.
in a another scenario, we don't have to have one entire LLM model just monitoring these AI agents. We can also have a small model for each of these agents. These they
Oh, like
Yeah, they have
SLM.
their own individual SLMs. Each agent has their own individual SLM, and all the three SLMs talk to the
Yeah,
large language model. So that also will give more
yeah,
efficiency as we go into like understanding the workflows and the issues within the metadata tracking or the streams.
yeah. Wow, fantastic. Um, and I just want to talk a bit about the sort of industry in general, sort of state of the
Mhm.
nation. I've had guests on before, and I'm always sort of interested what use cases you're seeing like around the industry in general. Have you seen anything that caught your eye recently, or anything interesting
Yeah,
going on in the
absolutely.
use
So
cases you're
there
seeing?
is this use case I've seen. I think NetSpace. So they are using edge computing as well, within the integrations. And I've never
Right.
thought of edge computing to use it like on-prem. That's actually pretty smart to integrate edge computing with cloud or IP-based integrations. So that one piece
Yeah.
of using, okay, just individual data, whatever devices we have on-prem for that specific, like wherever location, it's such a smart move to use edge computing to solve those issues. So that was one specific
Yeah.
use case
Wow.
that really like piqued my interest recently.
Yeah. Awesome. Okay. Well, I'd just like to say thank you, TJ. It's been fascinating having you on the show, and we share some similar parallels with starting in tech. Being full-time employed, going into the consulting and strategy, and now AI.
Hmm.
So, and the research paper, yeah, I hope it does well, and I hope it gets implemented in a broadcaster
Yeah,
soon. Eh?
I hope so too. Yeah, thank you so much for having me, Ben. This was a pleasure.
Thanks for listening to Reinventing Broadcast. Subscribe for more on AI content and the future of media. And visit ancast.tv for more info on Ben himself, the resources, other content, and news.